Well, hello guys, here Mr. G with another video. This time we're going to be solving a question for the grade 11, and this one is related to intermolecular forces as well as physical properties. I'm going to leave the question in the description below so you can answer the question before watching the video. But before we answer the question, don't forget to subscribe for the channel and thumb up the video. This question says, table below show the relationship between the melting point of three molecules, and they are the three molecules CH4, CF4 and CCl4. And I want you to note the following. If we look here at the periodic table, I'm going to take off, this one was from the previous video, we're going to see something. They all have in common carbon, but they have one of them hydrogen, the other one has fluorine, and the other one have Cl. So all of them have carbon, but they have the second element different. And if we look at them, all of them will have an increasing in mass as you move from hydrogen to chlorine. So the mass is actually increasing there. And I want you to know that, and I'm going to write like this, one arrow pointing down, and I'm going to make it a little bit longer. I'm going to make it a little bit longer. I'm going to write mass is increasing. The mass is increasing, moving down here. Question 3.1, define the term melting point. And we can say that a melting point is the temperature at which the solids and the liquid phase are in equilibrium. That you'll get to mark if you say that. Now, the next question. Explain the trend in melting point of the molecules in the above table by referring to the intermolecular forces of an energy involved. Very important question, and the way of explaining here is exactly the same as you would have to do in grade 12. So that is important to note here. So let's answer that question here. Question 3.2. Well, the first thing we're going to do is what we found out here. As you move down, the mass increases, right? So the molecular mass increases from, let's write it like that. Okay, so the first thing you have to say is that the molecular masses increases from CH4 to CCl2. You'll get 1 mark if you say that. Second, we have to make sure that we say that all of them have London forces. Alright, so all three molecules will have London forces. Let's go back quickly here. And if we look carefully, and we maybe do the Lewis dot diagram for each of them. For instance, for a carbon, I'm going to do it in this carbon for the first one. For methane, we have this one here. That will be how methanes look like, guys. And this one is a non-polar molecule. So the intermolecular force between two non-polar molecules is London forces. The second molecule is CF4. We do it like this, and it's exactly the same. All of them look exactly the same. The difference is the atom that they have fluorine in this case here. There we go. And this molecule is also non-polar. And I'm not going to do the last one, it's exactly the same, but all of them are non-polar. Therefore, all of them will have London forces between the molecules. The intermolecular forces there will be London forces. Okay, that is important. All right, and this is the part we are saying here. All three molecules have London force. Now, we have to say that the strength of the London forces increase as you increase the masses. So we have to say that the strength of the London forces increase as an increase in molecular mass. We have to fix that word there. So what we have to do is to erase this one. With an increase in molecular mass. And then therefore more energy is needed to break the intermolecular forces. And then to finish, all you have to say is that more energy is needed to overcome the London forces in the molecules with a higher boiling point. The stronger the intermolecular forces, guys, the more energy is required, is needed to break the intermolecular forces. All this is important. This one is 4 marks, guys, and it is going to be very similar in the grade 12. The only difference in grade 12, we're going to focus on organic molecules. So So let's go to the next question, 3.3. Which molecule in the table will have the highest vapor pressure? And I want to point out something here. Vapor pressure, higher vapor pressure will have lower melting and boiling point. And this is a very important thing to have to learn. Higher vapor pressure, lower melting and boiling point. And even more, weaker intermolecular forces. I'm going to write it in symbols like this. That is important, okay? So that is very, very important. And therefore, which molecule in the table will have the highest vapor pressure? The one that have the lowest melting point, and that one will be CH4. So the answer here will be CH4, and you will get 1 mark for saying that. Explain the answer by referring to the data in the table. So all you have to say is it has the lowest melting point, and we are done with that. It has the lowest melting point. That is another mark for that. Water is a smaller molecule than CCl4, but water has a higher melting point than CCl4. Explain this observation by referring to the type of intermolecular forces involved. Now we have to compare water with CCl4. We don't have a space here. Let's go to a new page. Now in this case we're comparing water, H2O, and we are comparing an CCl4. Okay, we're comparing those two now. What is very important to note here? First of all, CCl4 is a non-polar molecule. All right, with London forces. That is important. But H2O is a polar molecule which have hydrogen bond. Water has hydrogen bond. Hydrogen bond is stronger than London forces. So hydrogen bond is stronger than London forces and stronger than any other force. It's a stronger intermolecular force. As it is stronger than London forces, more energy is needed to break the intermolecular forces, therefore have a higher melting and boiling point. This is what you have to say, and if you say that, guys, you will get a mark. Let's give you the marks here. Now all this one must be written in a paragraph. First of all, you have to identify that this one have London forces, all right, and you have to say that this one have hydrogen bond. Okay, wait, hold on, because it's only 2 marks for this question. There is 1 mark for saying that CCl4 have London forces and H2O have hydrogen bond. So there's 1 mark for saying both of them, and then is 1 mark for saying that hydrogen bond is stronger than London forces. That is the 2 marks, but it could be the full explanation. Actually, all I did right there. And then to finish this question, write down the name of the intermolecular forces that will exist in a mixture of H2O and CCl2. Guys, it's between a polar and non-polar. So the name of the intermolecular forces will be dipole-induced dipole forces. If you identify the type of intermolecular forces, the type in terms of polar or non-polar, you can easily determine the type of intermolecular forces here. And the answer is dipole-induced dipole. 2 marks for saying that. Okay guys, so this is the question. This is a very good question in terms of intermolecular forces. I know some learners struggle with the topic, and it's quite important for the grade 12, and you guys are practically in grade 12. I hope it helped us. Thumb up, subscribe for the channel, and then next time we're going to be working with this is gases law. This one is the gases law. We're going to work with this one next time, so don't miss the video. But thank you for watching. I'll see you next time. Mr. G here.